evening and welcome. Tonight we're going to be going over the stars in the night sky for the month of April. As usual, we're going to look through the stars of the northern hemisphere. Then we'll look at the stars in the southern hemisphere. We'll talk about a constellation that is prominent in the night sky at this time of the year. And then we'll learn a little bit more about space. So let's just dive right in and get started with the northern hemisphere stars. On spring evenings, several bright stars stand out. Orange Arcturus in Boötes, Spica in Virgo, Procyon in Canis Minor, and Regulus in Leo. Now is a good time to get familiar with Leo and to find the other lion in the sky next to him, Leo Minor. Identify the lion by the distinctive pattern of stars known as the sickle, outlining his head and chest. Just to the south of Leo, 3 stars mark the constellation of Sextans. Let's see if we can find some of the stars they were talking about. So first one was Arcturus in Boötes. Arcturus is right there. Get you a better shot of the sky. There we go. Spica in Virgo. Let's see. Virgo would be this way. Virgo. Spica. Procyon in Canis Minor. Let's see. Where's that little dog? It should be down here, right? Canis Major. Canis Minor. And Regulus in Leo, which is right there. Let's learn a little bit more about the constellation of Leo. According to Greek mythology, Leo was the cave-dwelling lion killed by Hercules. Regulus, the brightest star in this well-known constellation, is located at the base of the sickle. When viewed through binoculars, a companion star can be seen. And there's Leo Minor, which, let's see, right there, Leo Minor. A much smaller constellation, Leo Minor represents a lion cub. Curiously, when Greek letters were assigned to this constellation, Alpha was left out, so the brightest star is actually Beta. And here's Sextans, which is right here in the sky, just below Regulus. Johannes Hevelius, a Polish astronomer, introduced this small constellation in the 17th century. It represents a sextant, which was used to measure star positions. Except in very dark skies, binoculars are needed to locate its stars, as even the brightest is only 4th magnitude. And you know what that means if you saw the March video for this series. I love this binding. Let's flip over to the southern hemisphere. Very carefully. Here we go. The southern hemisphere stars. There's our night sky, and take a look at it. Look at all these stars all together. It's so pretty. Let's see. It says, the southern sky is a mass of stars at this time, and as nights get longer, sky watchers in the southern hemisphere can look forward to a good show. Brilliant constellations line the Milky Way, including Lupus, Centaurus, Carina, and Canis Major. Hydra, the water snake, moves along the zenith, the point in the sky that lies straight above your head. Look for Crater hanging below Hydra to the north, and Pyxis and Antlia between Hydra and the Milky Way. So let's see if we can find those. We have Lupus, Centaurus, Taurus. There's Carina Centaurus. And Canis Major. There's Sirius. Hydra's up at the zenith. Here it is. And it said crater. Crater. Right there. And Pyxis and Antlia between Hydra in the Milky Way. Antlia and Pyxis. Let's read about crater. Hello, book sounds. Crater represents a cup or a chalice, and its shape does seem to resemble an ancient drinking vessel. In Greek mythology, it was a goblet belonging to Apollo, and a story links it with nearby Corvus the crow and Hydra. Its 4 chief stars are all about 4th magnitude, with Delta being the brightest. Let's find Corvus right here. Corvus the crow, which, does anyone watch Ephemeral Rift? Corvus is one of my favorites. Dr. Corvus Clemens. Pyxis and Antlia. Now, as I always say, I've never even been to the southern hemisphere, so I've never seen the night sky in the southern hemisphere, so I'm not very familiar with some of these names. So I'm not sure if it's Antlia or any other. I don't know how else to pronounce it, so I'm just going to go with Antlia. If you know, tell me in the comments, because I do want to know. It says, both Pyxis and Antlia were discovered in the 18th century by the French astronomer, here comes my French, Nicolas Louis de la Caille, who mapped some 10,000 southern stars. Pyxis represents a magnetic compass, while Antlia depicts an air pump, which was invented during the 17th century. Awesome. Pyxis and Antlia. I guess the compass, like the arrow in the compass, but I'm not sure how this looks like an air pump, but okay. Bravo, Nicolas. Did you know, in the constellation of Pyxis is a star called T Pyxidus. Although it is very faint, the star has repeatedly flared up to almost naked eye visibility. Astronomers saw 5 outbursts between 1890 and 1966 and are still waiting for the next one. That's really exciting. Astronomers have found a faint dwarf galaxy in the constellation of Antlia. It is one of the smallest known, with only about 1 million stars. Only 1 million stars, you guys. It's so small. Only 1 million. Alright, let's carefully turn the book around. My cat's in my lap and he's annoyed at the noise, but he doesn't appreciate book sounds like we do, does he? Here we go. So this month's constellation is Virgo. Let's learn a little bit more about Virgo, and then we'll look at the picture over here. In Greek legends, Virgo the Virgin represented the corn goddess Demeter. Its brightest star Spica, Latin for ear of wheat, refers to the grain held by the figure. Visible from both hemispheres, the constellation is the second largest in the night sky and is well known for its galaxies. Virgo is far from, can you see? There we go. Virgo is far from the dust clouds of the Milky Way, so we have a clear view of the more distant Virgo cluster of galaxies. In all, there are about 2,000, including spirals, ellipticals, and irregular galaxies, which we'll probably learn about maybe in a month or 2, I suppose. However, only the brightest are visible with small telescopes. At about 50 million light years from Earth, the galaxies appear very small and faint. So this is a picture of the whole constellation of Virgo. And this little box here shows you some of the galaxies in the constellation, which is what this picture is. Isn't that remarkable? Look at all of these. So Next up is the Sombrero Galaxy, or M104. The wide, flat disk and central bulge of this galaxy make it resemble the Mexican hat that gives it its name. It is a spiral galaxy seen almost edge-on, and the dark line around the brim of the hat is the dust lane. The galaxy lies to the south of the other Virgo galaxies and is closer to us at about 35 million light years. Let's read about this quasar. Quasar 3C273. Situated near Eta, 3C273 is a faint star-like object. Though 3 billion light years away, it is the nearest example of a quasar, a galaxy with an extremely bright and powerful center. This X-ray image shows the quasar firing out a jet, evidence that it contains a central black hole. Very interesting. Let's read about elliptical galaxy M87. At the heart of many large galaxy clusters lies a giant elliptical galaxy, and M87 is Virgo's biggest. It is a true giant, containing some 900 billion stars, compared with our own galaxy's 100 billion stars. Like other giant elliptical galaxies, M87 has become big by swallowing nearby galaxies. And let's read about this spiral galaxy. Can you see? I want you to see the whole thing. There we go. Spiral galaxy M61. There's the spirals. Although its brightest galaxies are ellipticals, the Virgo cluster also contains many spirals. M61 is one of the brightest and is classed as a barred spiral. At a distance of 60 million light years, it lies toward the edge of the cluster on the side farthest from us. And let's read about Edwin Hubble. In the 1920s, American astronomer Edwin Hubble, 1889 to 1953, showed that mysterious spiral nebulas were galaxies beyond the Milky Way. He proved that the galaxies are all rushing apart, traveling faster the farther they are from us, which means that the whole universe is expanding. And if you're wondering where you've heard that name before, it's because the Hubble telescope is named after him. All right, let's see what we're going to learn about this month. Let's hear that again. Anyway, wait, what does this sound like? Not bad. My cat doesn't like that. So tonight we're going to learn about clouds in space, otherwise known as nebulas. Let's see. The space between the stars is not empty, but contains clouds of gas and dust. In some places, thick dust clouds look like dark patches on the sky because they hide more distant stars. But dust can also shine by reflecting starlight. When there are very hot stars in a gas cloud, the ultraviolet light they emit makes the gas glow. Astronomers call the dark and bright patches nebulas. Nebula is the Latin word for cloud. Some stars are surrounded by their own nebulas, where they have blown away layers of gas. In photographs, bright nebulas have beautiful colors, but human eyes are not sensitive enough to see the colored light. Even with large telescopes, they look white or greenish. That's interesting. It's too bad we can't see these brilliant colors with our own eyes. let's learn about emission nebulas. Clouds of glowing gas are called emission nebulas. The gas atoms emit their own visible light after absorbing ultraviolet light given off by a white-hot star. The color of an emission nebula depends on the mix of gases in it. Most of the gas in space is hydrogen, which gives out a mix of red and blue light. So emission nebulas appear a shade of pink. Clusters of very young stars are usually surrounded by an emission nebula because they cause the gas cloud in which they formed to glow. This is a picture of the Pelican Nebula, an emission nebula in the constellation of Cygnus. And this is a reflection nebula. Isn't that beautiful? Let me get you a better shot. There we go. My desk is too small for this book. Reflection nebulas. We have emission and reflection. Reflection nebula. Dust is common in space, but it is not the same as household dust. It is mostly made up of particles of carbon mixed with ice. These particles are similar to smoke, and just as wood smoke appears blue, so do certain nebulas when they reflect starlight. However, the color of the stars inside the nebulas also has an effect. The nebula NGC 1977 is a beautiful example of a reflection nebula. This is what they mentioned, nebula NGC 1977. It's part of the Orion Nebula. Let's look at this big picture over here. There we go. Isn't that gorgeous? It says many nebulas. In this area of sky near the star Antares in Scorpius, you can see examples of emission, reflection, and dark nebulas, creating an unusual mix of colors. Sigma Scorpii is at the center of an emission nebula, while the other stars are surrounded by reflection nebulas. Where there is no star nearby, dark nebulas are silhouetted against the starry background, which you can see right there. This is the reflection nebula around 22 Scorpii. So it's blue. And down here is Antares, a red giant star that produces a yellowish reflection nebula rather than the usual blue. Antares is a bright one. That's an easy one to find in this night sky. Let's see, this is Sigma Scorpii, the only star in this region hot enough to cause an emission nebula. What's up here? It's Rho Ophiuchi. At the center of the reflection nebula IC 4604. Let's talk a bit about dark nebulas. See it all? Yeah, perfect. This is a really famous picture from the Hubble telescope, I believe. I believe it's called the Pillars of Creation, but it has a formal name, of course. A dusty cloud that is either very dense or has no star nearby to illuminate it is usually visible only when it is silhouetted as a dark area against a starry background or an emission nebula. Some small, rounded, dark nebulas are known as Bok globules. Now that's a trigger word. Bok globules. After the astronomer Bart Bok, who suggested that they may be sites of star formation. Larger clouds, such as the Eagle Nebula, sometimes have long shapes called elephant tusks protruding from them. Stars forming inside become visible as these pillars are eroded away by ultraviolet light from nearby hot stars. You can see the Eagle Nebula right there. The Eagle Nebula has dark columns of gas in which stars are forming. And we have a little segment down here about this nebula. Move this up here so you can see. Alright. Behind the clouds. Dust clouds prevent optical telescopes from seeing what is behind them, but they do not absorb infrared radiation and radio waves so easily. Astronomers use telescopes designed to receive infrared, microwave, or millimeter wave radiation to peer through dust and see what is beyond. The infrared image of part of the Eagle Nebula, which is this one, reveals large numbers of stars that are invisible in the picture of the same area in ordinary light. So this is this nebula, these clouds. You can see the clouds right here. But when we get an infrared image of this space, it looks like this. You can see all the beautiful stars. I love this picture. Isn't that gorgeous? Looks like glitter. I'm having a moment where I'm thinking about, like, straight above my head right now, the sky looks like glitter. This is right above us, inside our planet, outside our solar system. It's too much to think about, too overwhelming. Let's read this Did You Know box. Other types of nebulas are planetary nebulas and supernova remnants. Both of these nebulas consist of shells of material thrown off by stars nearing the end of their lives. Nebulas are sometimes named after something they resemble. Examples include the Witch Head Nebula, Thor's Helmet Nebula, and the North American Nebula. Interesting. I wonder who gets to pick those names. But anyway, that is it for this month. The best sounds. Okay, I'm done playing. Thank you so much for watching. I hope you found this video relaxing and educational. And I hope you have a very good